In this video, we're going to explore the basics of working with data in Java. We will be delving into a variety of topics like primitive data types, arithmetic operators, and variables. Generally speaking, most pieces of information can be thought of as either textual, numeric, or binary in nature. And by binary, I mean can be thought of as having two states. For example, yes, no, or true, false type data. In computing, these are referred to as Booleans. Most programming languages classify information into data types with common characteristics. Data types are necessary for a couple of reasons. First off, a computer needs to know how to intelligently allocate resources needed to work with data. And the compiler needs to know the types of data involved in operations to know what to do. For example, adding two numbers together should be treated much differently than adding two words together. For these reasons, Java employs aspects of something called type safety. Simply put, this means that you must be explicit about the type of data you are working with. Initially, we will be working with 8 so-called primitive data types. Primitive data types are how Java lets programmers represent basic, low-level information. Later, we will add reference types to our toolbox, which instead refer to higher-order, complex objects. The 8 primitive data types can be broken into Booleans, which represent true-false information, chars, which represent single characters, escape sequences, and so forth, and 6 numeric types, each supporting different ranges of values and degrees of precision. You will hear some people pronounce the primitive data type for characters as chars, and others will say chars. Here is a closer look at all 8. The numeric types are listed from smallest to largest in terms of capacity. As a programmer, it is your job to choose the correct data type for the situation. For example, if I need to store the number of tardies a student has in a class, I would pick a smaller integer type like short or int. If I needed to store someone's GPA, I would need to pick a floating point data type because they can represent info to the right of the decimal. In that case, a float would do the trick. Working with data in Java, in some respects, resembles what you have done in math courses throughout your academic career. In particular, data of different types can be manipulated through expressions you write. We even use common terminology. For example, the symbol used to perform the data manipulation is called the operator, and the pieces of data involved the operands. You can provide expressions that evaluate to a result in your code, or you can work with fixed values known simply as literals. There are 5 standard arithmetic operators in Java: addition, subtraction, multiplication, division, and the remainder operation. The percent sign is known as modulo, but you will often hear this referred to simply as mod. Keep in mind, operators can be ordered manually with parentheses, just like the P in PEMDAS. And one big thing that all programmers need to know is that dividing by 0 should always be avoided since it is undefined. Operators have different level of precedence, meaning that some types of operations are applied before others. Please keep in mind that operator precedence in Java differs from the PEMDAS rules you may be accustomed to. In Java, there are multiple levels of precedence in which operators are grouped. From there, expressions are evaluated from left to right. So-called multiplicative operations are at a higher level of precedence than so-called additive operations. Let's look at a simple example. You might think that the program should output the value of 1, but in Java, multiplication and division are of equal precedence. Therefore, the expression is evaluated from left to right, resulting in 10 being divided by 5, and its result 2 being multiplied by 2, resulting in 4. As we discussed, data types are important because they give operations context. Case in point, when you want to join strings together, you can use the same addition operator as you traditionally would with numbers. If Java detects that one of the operands is a string, the resulting data type will be a string. The fancy word for this in computer science is concatenation. Let's take a look at some examples. Some of the results may seem unexpected, but this is simply Java's rules of precedence at play. In many cases, the use of parentheses will allow you to ensure that your expression yields the results that you expect. Because data types have such an influence over the results of expressions and the like, It is often necessary to explicitly convert from one data type to another in your programs. This process is referred to as casting. Think of it like how a handsome prince is cast into a frog. The syntax for casting is pretty simple. Simply place the type you want to convert to within parentheses, immediately preceding the value to convert. Casting is necessary because often the results of an expression may not be what you desire due to the data types involved. For example, when you divide whole number data types, the result will be truncated to a whole number, and the part right of the decimal will be lost. However, if at least one floating point data type is involved, then the part right of the decimal is preserved. In other words, the result will be a floating point number. Let's look at how a cast could influence each. In the first example, casting one of the operands to a floating point number like a double preserves the part right of the decimal and yields a floating point number as the result. On the other hand, if I'm seeking a result free of a remainder, I could cast any floating point operands to whole numbers like an int, and a whole number would result. Now that you have a firm grasp of data types and the operations you can perform on them, let's talk about how you will actually be using them. In your programs, you will be creating variables, each with their own name and data type. Think of variables like storage locations for data in your programs. The variables you create will be able to store or reference values useful to you in your programs. It's important to note that whenever you create a variable, a certain amount of system memory is allocated behind the scenes. Variables need to be declared before they can be used. In other words, Java needs to know the name you intend to use and the corresponding type of information you seek to reference or store within it. When you declare a variable, it is initially empty. It is uninitialized. When it comes time to set the value of one of your variables, you use what's called an assignment statement. Start with the name of your variable, followed by the assignment operator, the equals sign, and the value to assign to that variable. Please note that the equals in Java does not mean equality. It means assign the value on the right to the variable on the left. Many times, you will want to declare and provide an initial value for a variable up front at the same time. You can do that by combining the declaration and assignment statements as you see here. You can also create multiple variables of the same data type at once by separating them with a comma. You can even mix variations of initialized and uninitialized. In addition to the basic assignment operator, there are so-called augmented assignment operators, which give you a shorthand way of updating the value of a variable. These are available because it is so often that you manipulate a variable's value and then assign the new value back to itself. Here is a closer look at the 5 augmented assignment operators in Java and their equivalent clunkier matching expressions. An even more common scenario you will encounter is when you want to increment or decrement a variable by the value of 1. Use the ++ operator to increase a variable's value by 1 and the - operator to decrease its value by 1. One special note about variables and data types. You need to be careful of the data types you declare your variables with. If you don't, you will undoubtedly run into issues. Here's an example of just such a case. In this case, we declare an int, but we're trying to initialize it with an expression which results in a floating point number. This is not permissible because Java will not convert information in such a way that you lose precision. The only way that this operation would be valid would be to either employ a cast or to change the data type of the variable itself to something like a double or a float.